Cool. Looks like we're ready to go. Thank you. Thank you very much to the FOSSASIA organisers for the invitation to talk again. I think this is about my 4th event, so it's a really exciting experience being part of FOSSASIA and my first time in Vietnam as well. So it was great to see lots of students as well. It reminds me of a very long time ago when I was a student. This talk is a slightly strange one. Normally I spend quite a lot of time talking in depth about 1 or 2 technologies. So this is a bit of a new concept for a talk. I thought, well, I don't have any new technology to talk about. What if I talk about all of the technologies that I've used in the last 7 years? So that's the background to the talk. So whether it works or not in 30 minutes in particular is something we'll find out, and I'll start my timer now. So yes, definitely in the Netherlands, when I was there a few years ago, there are 30-minute bike parks. I don't know whether that's a thing in Vietnam or not. Here are most of the technologies that I'm going to be talking about. Actually, not all of them. There's a few I decided not to include, but about sort of 90% of those are the ones that I will be talking about. What do they have in common? Well, first of all, I work for Instacluster. It's a company that was bought recently by another company called NetApp. I've worked as the technology evangelist for Instacluster for about 7 years now. And we started out by providing a managed Cassandra service. And over the last 7 years, we've added a few more, including Postgres, Redis, Kafka, OpenSearch, and Cadence. So I'll be talking about those and more technologies as well. So the 30 that I'm going to talk about are complementary and can be used together. And in fact, I have used them all over the last 7 years, building realistic demonstration applications which do something interesting and more or less work most of the time, which gives me something to talk about at conferences. Some people might recognize this particular creature. It's a strange toy that I found recently in the supermarket. What is it? Well, I believe it's called a Pokemon. But this one seems to have escaped. When my kids were growing up, Pokemon used to live inside one of these other things called a Game Boy. So I don't know. Obviously, they recently have managed to escape the virtual world into the physical world. So that gives me the idea for the format for the talk. Basically, I'm going to have a look at every technology, give you a very brief overview, have a look at what superpowers the technology has, things to watch out for. So this is a Pokemon. It's Charmander. It's a fire lizard. It has various superpowers, including evolving to a flying, fire-breathing lizard. But it doesn't like water, so you have to watch out for water. I'll also look at some use cases and maybe for some of the technologies, what's new and interesting on the horizon for them. So countdown, 30 minutes to go, or count up, actually. I'm doing it in the reverse order to a countdown. So number 1, Apache Cassandra. I've got pictures that hopefully illustrate the main idea behind each of these technologies. So this is an old photo from an office typing pool where you've got a lot of people typing on typewriters. So this is a fast writing mechanism. What is Cassandra? It's a NoSQL horizontally scalable key value database. Superpowers, well, fast writes. It's a wide column store. It has clustering columns which are good for hierarchical data modeling. For example, geospatial is one use case I've used it for, and it's got inbuilt multi-data center replication. So it's quite impressive. I have used it to build, for example, an anomaly detection system, which can process 19 billion anomaly checks a day. Cassandra was the main persistence mechanism that I used as part of that application. I've also used it to build a global low latency fintech application. This is one where you have to have redundancy within a geo region and low latency within that region as well. So that more or less comes free in Cassandra. Things to watch out for, well, the query language CQL is not SQL. So if you're familiar with SQL, you have to sort of unlearn a few things. It's got quite a different data model to a standard SQL database. You have to design it for reads, and denormalization of tables is, well, normal, in fact. Consistency is less than traditional SQL databases, and reads are slower. In the new version 5.0, vector search, like quite a lot of open source technologies, is now part of the technology as well, which opens up a whole lot of new use cases potentially. Second technology, how we're going? Yep. Apache Spark. The photo I've got here is a car factory assembly line, so it's like large scale building of things. What is it? It's a cluster batch stream processing system for analytics and machine learning. Superpowers, it's in memory and a strange square box, and is fast as a result. It's got good support for machine learning, and it can be used quite well with Cassandra using the wide columns as a feature store. It's really great for heavy transformation operations at scale. A use case, I haven't used it very much. It was actually the first technology I used when I joined Instacluster. I used it for machine learning of Cassandra monitoring data. So it used a whole bunch of technologies, including Spark streaming and ML lib and data frames, and it worked pretty well. Watch out for the fact that it needs lots of RAM, otherwise you get out of memory errors. Spark streaming is near real time using micro batching, so not quite as fast as, say, Kafka. Coming up in new versions, Spark Connect, and NetApp also runs Ocean for Apache Spark as well, which is quite a good way of running it on Kubernetes. Third technology, Apache Zeppelin. Again, this is one that I used a long time ago and haven't really used ever since. It's a web-based notebook for data exploration. It's an interactive style notebook, so you can type stuff in and see what's happening interactively, and it's got good support for Apache Spark. You have to watch out for the fact that it uses a lot of resources itself, and we also, at Instacluster, we don't directly support it with our products anymore, but what's new on the horizon is Jupyter Notebook. So this has really great Kafka and Cassandra integration. Technology 4, Apache Lucene. This is a bit like a librarian using an old-fashioned card catalog to look up various things about books. It's a fast, full-featured search engine. One of the superpowers it has is there is a Lucene plugin for Cassandra, which gives Cassandra enhanced search. It works as a Cassandra secondary index, and it supports vector search as well. You do need to watch out for performance. We currently support it at Instacluster, but I don't think that support will be continuing much into the future. The use case I found useful for was for geospatial anomaly detection. So as part of that system I mentioned before, I added the ability to look for anomalies within a certain geospatial area, and that seemed to work pretty well. Fifth technology is Apache Kafka. It's appropriate maybe, given that we're in a postal university, I think, that the metaphor I've got here for Kafka is a postal delivery service. It's a distributed pub-sub messaging system. It's really fast. It's highly distributed and horizontally scalable, available, and durable. It provides buffering of messages and message replay as well, which are quite useful and a bit different to standard messaging systems. My use cases included the very first one I built, a Christmas tree light simulation, which is a bit quirky. But the idea of the simulation gave me an idea for building a more realistic IoT logistic system involving the movement of goods using trucks and warehouses and checking for safety and environmental conditions and things. So it was a pretty complicated application. Built mainly with Kafka, although I did cheat and use the Guava event bus for the notification side as well. It's also part of the anomaly detection system that I've mentioned. Basically, the Kafka producers and consumers were running as part of this application, talking to Cassandra at the back end. Things to watch out for: too many topics or petitions can impact throughput dramatically. In the newer versions, Kraft is replacing ZooKeeper, and this gives faster metadata operations, and maybe we suspect even faster data workloads, which is a bit surprising. We weren't expecting that. Tiered storage is coming in a new version, and end-to-end client monitoring is something new that's coming soon as well. Number 6, Apache Kafka Streams. I think that guy survived going over Niagara Falls. I'm not sure. It might be before he went over. It's a stream processing API and client for Kafka. Basically, it reads from the Kafka cluster, does stuff, and then writes back to the Kafka cluster again. It's great for complex stateful stream processing operations, for example, joins over multiple topics, and also over time windows and multiple topics and state stores as well. I have used that a few times. As part of the IoT application, I built a Kafka Streams application that detected if trucks were about to be overloaded and stop things being put on if that was the case. Things to watch out for: complex stream topologies, which you get more or less as soon as you build anything realistic. There's a topology diagram on the right-hand side of it, a very simple application, which means that debugging can be tricky and performance is also a problem sometimes. There are some potential alternatives on the horizon, including other Apache projects like Apache Flink and Rising Wave, which I will actually mention. Number 7, Apache Kafka Connect. This is a bit like the telephone switchboard operators connecting calls. It's a Kafka API for streaming from source to sink systems via the Kafka cluster. So it gives you heterogeneous integration. It's code-free. You just configure the connectors and they work. And it's independently scalable as well. So the connectors run on independent Kafka Connect clusters, independent of the actual cluster, of the Kafka cluster itself. My use cases, well, I've used it to build, for example, a zero-code data pipeline. There's 2 different versions of more or less the same pipeline, getting open source or open data from a REST API for tidal data, and then putting it into either OpenSearch or Postgres. Things to watch out for: finding an open source connector that does what you want and works is actually non-trivial. So evaluating and selecting connectors is an important part of the process. Error handling doesn't necessarily come for free, and it will blow up depending on what has gone wrong. So you have to watch out for that. And source and sync system scalability is also something to watch out for. Debezium, which is a CDC system, uses, or in some cases uses, Kafka Connect as well. Technology 8 is Kafka Mirror Maker, version 2 in fact. And this is about Kafka replication. So it replicates Kafka topics between different clusters. It uses Kafka Connect, but reads and writes from and to different Kafka clusters. It has built-in topic renaming, which prevents loops, and it supports complex bidirectional topologies. So there's lots of use cases for having multiple Kafka clusters. For example, if you're wanting to migrate systems, geographical distribution, to ensure low latency for IoT or edge sort of use cases, etc. Things to watch out for: bidirectional flow requires 2 Kafka Connect clusters to be running. Duplicate events from overlapping topic subscriptions can be an issue, and use topic renaming and the default source cluster alias to prevent cycles and infinite topic creation, which is something you don't want to happen. For me, and it's not a new feature particularly, but one I hadn't realized had been introduced back in 2020, is the automated consumer offset sync across clusters, which at the time I thought was going to be really helpful, but I haven't tried it yet. Technology 9 is Apache Camel, another Apache project. You'll notice those popping up fairly regularly in the talk. It's an integration framework. It provides inbuilt components for connecting between different technologies, but as part of that, there's a sub-project, the Apache Camel Kafka Connectors, which is a whole set of open source Kafka connectors. There is a large number of open source Kafka connectors available, about 172 or 179, depending how you count. And the clever thing is they're actually auto-generated from the Camel components, so they will always be there even for new components as they are added. Things to watch out for: configuration. You need to read at least 3 different documents to find out how to configure the Camel Kafka components. Some connectors are both sources and sinks, and depends on the configuration. And what's new is something called camelets in the new version, and sometimes camelets appear in the configuration as well. Technology 10, Kafka Parallel Consumer. It's a multi-threaded Kafka consumer. It's got the main superpower is being multi-threaded compared to the default single-threaded Kafka consumer, which gives you higher concurrency with less consumers and partitions. It's great for when you want low latency and high throughput, when you have slow consumers, you can't speed up. And it's a replacement for a hack that I used using multiple pools to speed up my anomaly detection application. Watch out for the configuration. There are lots of different options compared to normal. The ordering mode can be partition, key, or unordered, which gives you increasing concurrency, but increasing chaos as well, potentially. You have to decide how many threads you'll run as well. And in the new version, there's apparently different commit modes as well. Technology 11 and 12, I'm cheating, I'm combining another couple of Apache projects, ZooKeeper and Curator. And yeah, it's a myth that everything is going to eat you in Australia in terms of animals. Koalas probably won't eat you, but everything else will. So it's a distributed system and coordination meta-management technology. It provides high consistency, availability and performance, mainly on the read side though. And there's a lot of use cases both within and outside the Apache ecosystem. Until recently, it was used in Kafka and Pulsar, etc. I used it to build my own sort of demo application of the dining philosophers problem, which is a well-known computer science sort of 101 distributed systems problem. It is quite low level, which is why Apache Curator is useful. It's a high-level ZooKeeper client, and that provides sort of better abstractions for high-level concepts. It does have scalability limitations. It's quite slow for writes, and the maximum cluster size is basically 7 servers, so scalability is finite. In Kafka, Kraft has basically replaced it, and that gives you a lot faster and more scalable operations in Kafka. Kubernetes is my 13th technology. It's for automation of containerized applications. It's available on lots of public clouds. Pods are ephemeral and the main unit of concurrency, and it's very easy to scale applications just by having more or less pods. In some cases, too easy. You can get too many very quickly. I used it to run most of the application code for my anomaly detection system, so the Kafka producers and consumers were actually all running on Kubernetes. Watch out for pod and resource scaling. It's, yeah, as I mentioned, easy to create lots of pods. Sometimes there may be insufficient resources, or other times there may be too many resources, and your bill may be surprising. Tuning applications can be tricky. You have to optimize the number of pods versus Kafka consumers, petitions, Cassandra database connections, etc. So keeping an eye on what's going on is really quite critical as you scale up applications running on Kubernetes. There's a strimsy operator for Kafka, which allows you to run Kafka on Kubernetes available. 14 and 15, Prometheus and Grafana. More or less counting. Prometheus is for monitoring and alerting. Grafana is the graphing side of things. It provides instrumentation or agents to expose application metrics. There's lots of different types of metrics. I've used it for monitoring and scaling the anomaly detection application and my Kafka Connect data pipeline system. And internally, our monitoring API actually has a Prometheus version as well, so you can suck metrics out and use them in Prometheus and Grafana. You need a Prometheus server to run somewhere. Configuring Prometheus with Kubernetes can be tricky as well, and the operator is probably the easiest way of doing that. And also watch out for the recent change in the Grafana license, which may not suit your requirements. 16, 17, and 18, OpenTracing, OpenTelemetry, and Jaeger, and others. This gives you X-ray vision into your application. OpenTracing is for end-to-end distributed tracing. It gives you end-to-end distributed application visibility into traces, which is everything that's going on from one end of your system to another, using spans, which gives you the insight into individual steps. It gives you a visualization of system topology and time spent in each part of the system, which is really useful. Originally, I used OpenTracing and Jaeger. This needed manual instrumentation in the code. However, recently OpenTelemetry has become the new standard. This combines tracing metrics and logs. The instrumentation is mainly automatic, so you don't need to worry about it. And there are now lots of open source visualization tools, including things like Signos, Uptrace, and even OpenSearch, I believe. And potentially, I believe that OpenTelemetry is going to be used in the new client monitoring kit for Kafka coming up as well. This is just a screenshot of Signos, one of the tools I mentioned, giving a service map for another application that I haven't talked about yet. 19, PostgreSQL. You may know that the Postgres icon or emblem is an elephant, so yeah, it's quite a powerful technology. It's a powerful SQL database. It's more than SQL. It started out life as an object database, and there's still some of those features, I think, in it as well. It's extensible, and it has really good support for JSON. So using something called JSONB and GIN indexes, it gives you efficient search, storage and search of JSON data types. Watch out for scalability, which is okay vertically, but it's got limited horizontal scalability. It can benefit from connection pooling. In the newer versions, there is a PG vector plugin, which gives you vector search. And we have done some internal benchmarking, and I think we now have available a version that runs on NetApp Azure files, which is significantly faster than alternative file systems. FerretDB is another technology I'll briefly mention, which is a MongoDB front end, which works with Postgres as the back end. Number 20, Apache Superset, another Apache project. It's a powerful data visualization tool. It reads from SQL data sources and has lots of visualization and graph types, including geospatial representations like maps and things. I used it for the visualization of title data from my Kafka Connect pipeline, and it was really easy to integrate it with PostgreSQL and JSONB. 21 and 22. There we go. Yep. On time. OpenSearch and the OpenSearch dashboard. So this is a more scalable version of the librarian looking up the library catalogs. This is the one that was in the Library of Congress. It took up a whole city block underneath the library, apparently. It's the open source version of Elasticsearch. It's based on Lucene, which gives you powerful and scalable text searching. It's got support for ingestion, indexing, and searching of JSON documents. It's got an integrated dashboard for visualization and quite powerful computational linguistics support, which from a very long time ago, I remember studying some of these things like stemming, lemmatization, and other weird and wonderful things as well. I used it as the sync and visualization for my title data processing pipeline. And there's an example of some tied ranges over a period of time in that graph. Things to watch out for: the default mappings and ingestion may not work as you expect. For example, geospatial data using lat longs needs custom mappings and ingest pipelines. Reindexing seems to be a thing that happens all the time and is sort of annoying. With my Kafka Connect sync going into OpenSearch, I discovered some throughput issues, and you need the bulk API to have sufficiently high throughput out of Kafka into OpenSearch. And again, as we've noticed, it's got vector search, and a lot of technologies are now having that built in as well. 23 is Redis. It's a fast in-memory data structure server. It's got lots of data types. It's any sort of data type that you come across in computer science, it supports. It also, oddly enough, has a sort of fairly primitive pub-sub system that supports both connected and disconnected delivery, which is quite fast, but probably not very scalable. It also supports client-side caching for ultra-low latency. For example, the Redis client supports that. Watch out, pipeline tuning impacts throughput. It's often used as a cache to reduce the load on back-end databases. So you may not get improved latency depending on what else is going on, but you probably will get a reduced load, and I have an example of that coming up. What's new? Version 7 has Redis functions, which are executed on the server. And unfortunately, with 7.4, there's a license change as well. And I think there has been a fork now of Redis, which has the original license. 24 is Uber's Cadence. This is a picture from a long time ago of a railway signal woman. So it's all about switching trains and things around so they go where you want them to. It's a scalable code as workflow engine. It gives you the ability to run quite complex workflows, which are basically sequenced, stateful, long-running or scheduled steps. It's scalable and reliable using event sourcing. So workflows are basically fail-proof. History is replayed until the point of failure and resumed transparently if something goes wrong. So this is actually the technology that Uber uses for their food delivery side of things. Here's my example, which is, I think, the one I talked about last year at FOSSASIA. It's a drone delivery application. It's quite an interesting example of a complex system with multiple workflows integrated with Kafka, which provides coordination across various activities and things. And it gives you the integration of fast and slow systems when you combine it with Kafka as well. So there's quite an interesting synergy of different technologies. It uses Apache Cassandra and OpenSearch as backends. So we provide it as a managed service because it is actually quite tricky to set up and run yourself. You have to watch out, code must be deterministic because it's replayed on failure. So there's a few things where you have to use special functions for non-deterministic operations. Some interesting potential use cases for scalable push notifications. Uber actually uses it to push out lots of notifications at certain times of day to customers. And it's also potentially, I think, useful for running complex machine learning workflows as well. 25, Debezium. So this is a photo showing animals going from slow to fast, which is sort of what Debezium does. It's for change data capture. It captures slow database state changes and turns them into fast Kafka events. It uses Kafka, either Kafka Connect or some database-specific connectors, depending on the database technology. So you can use it to replicate databases of the same type or send events to different sync systems as well. I've used it a couple of times, experimentally, mainly with Cassandra and Postgres. Things to watch out for. The database-specific connectors need to be configured and in some cases run in the database. So you're going to need some support from your cloud database vendor at that point, potentially. The Debezium change data format is actually quite complicated. The actual content depends on the source database. Schemas may be inline or just an ID, in which case you may need the Kafka schema registry as well. And the schemas can change as well, and that might be part of the data. It's tricky to find Kafka Connect sync connectors that actually work correctly with this technology. Some issues include duplicates and ordering of data, latency, scalability challenges. And yeah, if it includes a schema ID, then you will need a Kafka schema registry to interpret the schema. Last year, we actually made this available on our managed Cassandra, so it should all work relatively straightforwardly at that point. 26, Karapace. It's an open source Kafka schema registry. It adds schemas to normally schemaless Kafka. It supports multiple schema formats, and the Kafka cluster itself is not directly involved. Karapace enforces the schema checks for clients only, and the obvious use case is with Debezium. Watch out for auto versus manual schema registration. Manual is safer in production. Schema compatibility modes, and evolution are all quite complicated, even for someone like me who's been doing computer science for a long time. So it's not a straightforward technology to use. 27, FerretDB. Is it a fish or is it a shark? It's an open source MongoDB proxy for PostgreSQL. It's compatible with MongoDB drivers on the front end. It's got pluggable backends, including PostgreSQL, and actually does use JSONB and the GIN index mechanism. And it has query pushdowns for efficiency and performance. So it's worth trying out if you're using Mongo or like a different backend. Rising Wave. This is the one that I came across recently and used briefly. It's a stream processing database, also available as a service. It's really good for stateful stream processing, and it uses cloud native storage. So it's a lot more scalable, perhaps, than Kafka Streams. It works with Apache Superset, so you can actually look at your streaming data using Superset, which is quite cool. My use case, well, this is the only thing that I've built with it. It's a Santa's Elves toy and box packing application. Basically, it uses streaming joins to match toys and boxes and make sure they're all put in the correct boxes. Things to watch out for, it's SQL compatible, which is not the same as a Kafka Streams DSL, so there is a difference there. Kafka keys are not propagated into it, and windowing has potentially different semantics as well. 29, we're almost there, TensorFlow. It's a neural network machine learning library. It supports incremental machine learning from potentially streaming Kafka data. And my use case was using it with my drone delivery system with Kafka Streams in the middle to produce features that the TensorFlow is then doing machine learning over the top of. Things to watch out for, well, machine learning over streaming spatio-temporal data with concept drifts is actually quite tricky. There's a time, space, bias, wild model accuracy oscillation, and you may need to really train and use multiple models concurrently for it to work. 30, well, I was going to put in something like Eclipse, which I use all the time, but actually invent your own, and I can talk about it next time. A couple of examples just quickly. Our customer-facing monitoring system is actually built on some of these technologies. We've got very large amounts of monitoring data being written into Cassandra. Originally, we used Spark, which had a very high load on Cassandra. We recently replaced that with Kafka, Kafka Streams, and Redis as a caching layer between the customer API requests and Cassandra. And that didn't actually improve the latency, but it significantly reduced the size of the Cassandra cluster that we needed. Finally, my drone delivery demo application, this was the initial version, but potentially you could supplement that with a couple of the other technologies that I mentioned. You could do something very similar to what we just saw, having Postgres at the back end, writing the data into Redis, and then using that as a cache for customers to be able to query their orders to see estimated time of arrival and delivery locations and things. And also internally, the drone operations people might be able to then use the same data and display it maybe on Apache Superset as well. So that's it from me. Thank you very much. There's my LinkedIn QR code. Check us out on instacluster.com. We've got a free trial of the technologies that we provide as a managed service, but the rest of them you'll have to bring your own and test them out. So thank you very much.